Welcome to today's class. I'm glad to have you here. Today, I want us to look at the electricity aspect of the alternative to practical physics. Now, looking at this diagram, of course, we have the diagram here. This diagram shows we have the rheostat or the variable resistor A to B, and then the sliding jockey or the slider C. Now we have a key, we have a source of electricity, this one, of course this is the nickel ion, and we have the Daniell cells, two of them. Across here we have the ammeter and the voltmeter put together. Now we'll read the instruction given here. They said an electrical circuit is set up as shown in diagram above. The position of the sliding contact C is adjusted on the rheostat AB such that the ammeter reading is I0. And of course, the ammeter reading I0 is 0. And the corresponding voltmeter reading V0 is read and recorded. The procedure is repeated for 6 other values of the ammeter reading I. In each case, the corresponding value of the voltmeter reading V is read and recorded. Now we have figure 3A and figure 3B represent the ammeter and the voltmeter reading respectively. Now on this side, we have a ammeter here and we have a voltmeter. Now check out the voltmeter reading. The voltmeter reading, which is the figure 3B. Now the range is from 1.0 up to 1.4. That means, and then everything is all the values range between 1.1 and 1.3. Take note of this. So once you are given this type of problem, the first thing, look at the meter reading, the meter range, whichever meter you are using. If you're using a meter, if you're using voltmeter, if you're using a galvanometer, look at the range. Now, this one is our ammeter. The ammeter, the reason why this one is the ammeter, of course, you know, ammeter measures current. And of course, we have I0, I1, I2, I3, down to I6. Now, the range is between 0 and 3.0. Now let's go back to our question. Now the question says, number I, read and record II, where I is from 1 to 6, and the corresponding voltmeter reading VI. Now of course this I is an integer from 1 to 6 respectively. II says, tabulate your readings. I. Plot a graph of V on the vertical axis against I on the horizontal axis. The next question says here, determine the slope S of the graph and the intercept C on the vertical axis. Now V question says, evaluate K is equal to C all over VP. And of course, the C is the intercept on the vertical axis against V0. V0, we shall determine the V0 from our voltmeter. Now, state 2 precautions you would take if you were performing this experiment in the laboratory. B, state 4 factors upon which the resistance of a metallic conductor depends. Now, BI says, explain the specific resistance of a wire. Now, having read the questions, let us go back. Now, everything hovers on I, question I. Read and record the ammeter reading. Now, for clarity's sake, this is the easiest of all the questions because this one, you only require, you're not going to take any other measurements with your ruler. And if you look at this point, no scale is given. All you need to do is to read correctly and the record. This one is very simple. read correctly, and record whatever value you have. Now, let us take the readings one after the other. So the only thing we are going to take here is just ammeter reading I and the voltmeter reading V. Simple. Now, we make our table. And after making our tables, we fill it up. Now, this is our table. Simple. We have the serial number, we have I, we have V. All we need to do is to fill up the table using the values we have. Now, reading from this, if we read the current phase, and of course, you have the I0, I1, I2, I3, I4, I5, up to I6. Now, look at the trend of the voltmeter. So as we increase the current, voltage gradually drops. So it is dropping from V0, V1, V2, V3, V4, V5, and V6. Now, the I1, of course, the scale here now is, this is 0, this is 1, 2, 3. Between 0 and 1, how many calibrations do we have? That is the first question we'll ask ourselves. Now, let's read it together. Of course, you will not add this first one. So this first one is 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means from 0 to 1 is 1. 1 divided by 10 will give us 0.1. That means each line is 0.1. So we have here 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1.0. Okay, now if we take a look at the V1, here is 1.0. The next line is 1.1. Now, between 1.0 and 1.1, how many calibrations do we have, or how many divisions? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means 1.0, 1.01, 1.02, 1.03, 1.04, 1.05, 1.06, 1.07, 1.08, 1.09, 1.1, 1.11, 1.12, 1.13, 1.14, 1.15. In that order. Now we'll take the I0 first. I0 here is 0. Now we have which is the first one now. When I is reading 0.00, what is V reading? The corresponding voltmeter reading for V0, and of course this is the pointer, where the pointer is. The pointer is at 1.3. So we write here 1.30. That is what you have. Now the next one is when V, sorry, let me place it properly so that you can read the two very well. Okay, so I2 is reading, and of course this is a 0.1. Now I1, please. When current is reading this one, we have here 0.1, 0.2, 0.3, 0.4. Here is 0.5. Now under I, we have 0.50. Now, what is the corresponding value of the V1? V1, remember, here is 1.01, 1.02 up to here. So we have here 1.2 here, 1.21, 1.22, 1.23, 1.24, 1.25, 1.26, 1.27, 1.28. So here is 1.28. You put it down, 1.28. Now this third one, which is the I2. Of course, reading from here, you have that the third one is 1.0. We'll write 1.00 here. Now, under V, the corresponding V2 will give us, now this is a V2. Remember, so if we count from here, 1.2, 1.21, 1.22, 1.23, 1.24, 1.25. So here is 1.25. You put it down. 1.25. Now, I3 now. Looking at this, so here is 1.0. 1.1, 1.2, 1.3, 1.4, 1.5. So you put it down, 1.50. Now the corresponding voltmeter reading will now give us, and of course, we'll have V3. V3 from here will now give us, if you read 1.2 here, 1.21, 1.22, 1.23. So we have it here, 1.23. Okay, the next one is I4, and I4 is reading 2.0. So we'll have it here, 2.00. Now the corresponding V4, of course, if you read directly here, it will give us 1.2. We'll have it as 1.20. Remember, you must be consistent with your DP. You must be consistent with your DP. 22.00, please. Now, the corresponding, if we have I5 now, since here is 2.0, 2.1, 2.2, 2.3, 2.4, 2.5. So we have here as 2.50. Now the corresponding V5 will give us, please be consistent with your measurement, please. This is V5. Remember, here is 1.1. Here is 1.2. So 1.11, 1.12, 1.13, 1.14, 1.15, 1.16, 1.17. That means it's 1.17. Okay, now the last but not the least, which is the I6. I6, looking at it from here, I6 is a 3.0, so 3.00. Now the corresponding V6 is this point. So you read from here to there. That is 1.1, 1.11, 1.12, 1.13, 1.14, 1.15. So we have 1.15. Now, assuming this, remember, if this is 1.3 and this pointer is in between, that means it will be 5. So it should be 1.35. So that is what it means. So if you look at this, no one is pointing in between. So when it is pointing in between, please know how to read it. You should take care of that, please. Now, having gotten our table of value, this is very simple. Having gotten our table of value, the next thing is for us to plot our graph. So let's plot our graph now. Okay, now the graph, once you get your graph, this one we're going to plot it on a graph sheet instead of on a graph board. So please pay attention to it because this is the normal graph you are going to meet. Okay, this is our vertical axis and this is our horizontal axis. Now we refer back to our question. Our question says, the question says, plot a graph of V on the vertical axis against I on the horizontal axis. You pay attention to this so that you don't plot the other way around, because once you plot the other way around is disregard of instruction, and once there is disregard of instruction, everything becomes 0. Now, what it means that if graph of V on the vertical axis, YI is on the horizontal axis. Now take a look at our table again. We are plotting these on the vertical axis, these on the horizontal axis. Now before we choose our scale, the highest value is 1.3 and the least value is 1.15 on the V-axis. Now on the I-axis, the highest value is 3, while the least is 0. Okay, now let us take our vertical axis first. So if we have highest value 1.3, the least value as 1.15. Okay, we label our axis. Remember, this is current. So here we'll label here current in ampere. We put it there. Now for our V, remember V is on the vertical axis. So V, we put V here, and the SI unit of V is V. Okay, that is the first thing. Please do not forget to indicate your axis and their corresponding SI units. All right, so we now we'll take a look at our values again. So if we take a look at our values again, V, the highest point is 1.3, the least 1.15. Now we can have here as 1.0. If we have here as 1.0 and have here as 1.05, we can have here as 1.10. We can have here as 1.15. Can have here as 1.20. We continue. We can have here as 1.25, and we have here as 1.30, 1.35, 1.40, 1.45. So having labeled this, now remember I didn't just stop at the highest value. Please complete that axis. Now here the least value of our I is 0, while the highest is 3. Now we can have here as you can have here as, let me have here as 1. Nothing stops you from having here as 0.5, 1, 1.52, 2.53. Nothing stops you. Okay. Nothing stops you doing that. So I can have here as 1. I can have here as 2. I can have here as 3, 4, 5, 6, 7, 8. Fill it up. Now it's time to plot. Now remember, this one did not start from the origin. This one did not start from the origin, because if it has started from the origin, here would have been 0.05 here. It didn't start from the origin. So you take note of that. So this one started from the origin because it's 0, 1, 2, 3, 4 in that order. So there is no need writing 0, 0 here, because this one did not start from the origin. Okay. Now the first thing we have is we are plotting 0 on the I-axis against 1.3 on the V-axis. Now the 1.3, this is 1.3. 1.3 against 0 on this. And of course, 1.3 against 0, this line is 0. So we can plot it here. We can plot here. Here is 0. We plot there. Now the second point we have is I-axis 0.5 against 1.28. Now let us see how our scale look like. Between here and here is 10 divisions. Here is 10 divisions. So we have here, that means each line here is 2. So we can have 1.02 here, 1.02. The next two lines, 1.02. Now, since there are 10 divisions here, and this is 1.0, this is 1.05, that means the first two lines, the first two division is 0.1. So we have here the first two, 1.01, 1.02, 1.03, 1.04, 1.05, 1.06, 1.07, 1.08, 1.09, 1.10. Now, since we are looking for, please, I will not be displaying this. I will display the table on the screen, so you look at the screen. Now, the second one is I am plotting 1.28. So since I'm plotting 1.28, that means I will have here as 1.25 here, 1.26, 1.27, 1.28 on this line, 1.28 on this line against 0.5. Now 0.5 is, since here is 1, since this line is 1 and there are 10 divisions here, so each line will give you 0.1. now I will come here, since here is my 0.28 here, now under this line I have 0.1, 0.2, 0.3, 0.4, 0.5. So here I'll plot here. This is where I plot. Okay. Now the next one is V 1.25 against I 1.0. So 1.25, already I have my 1.25 here. Now this other one will give me 1. So at this point, I column, you can see I here, you can see I will trace it down here. If you trace it down here, that means I am plotting somewhere here. Okay, now after that, the next one is 1.23 for V against 1.5. 1.23, this is 1.2 here. Let me look at 1.5. So here is on this line, here is 1.1, 1.2, 1.3, 1.4, 1.5. Now I will trace it up here. Since here is 1.20 and I'm looking for 1.23, so I will have here 1.21, 1.22, 1.23. So here I am plotting this point, so I will make my plot here. Okay, the next one is I am plotting 1.20 on V axis against 2.0. 1.20. Now this is 1.20 here. Now on the I axis I am plotting 2. So of course this is 2 here. It's very clear. So we have here plot here. Now the next one is a 1.17 against 2.5. 1.17. So since here is 1.15 here, 1.16, 1.17, I will trace it down to 2.5. Let me repeat it again. This line is 1.15, and of course 1, 2, 3, 4, 5. This here is 2.5 on this column. Now if you read up, that means, and take a look at this one, 1.15 here. So the next two line is 1.26, 1.27. sorry, 1.17 here, please. So I'll plot at that mark. So I'll plot here. Okay. Please remember to use sharp pointed pencil. Now, the next one is 1.15, and of course 1.15 for V is clearly written here. So this is 1.15, and I am looking for 3.0. So here is very clear. I'll plot here. Now these are the plotted points. If you look at the range, 1, 2, 3, 4, 5, 6, 7. So these are the plotted points. The next thing now is to draw my line of best fit. So for me to draw my line of best fit, let me adjust it. Now you put your, if I put my ruler, almost all of them on the line, but not everything on the line. So remember this one is off here. Now my line of best fit, okay, I cannot draw. So if I draw, I cannot have it like this. Make sure this one is cutting both axes. Now this is my work, and with this now you can have that this one is off the line, while this one is off the line here. So how many entered the line? 1, 2, 3, 4, 5 entered the line. So 2 is remaining. These 2 is distributed. This one is above the line. This one here is below the line. So it is a perfect line of best fit. Now the next thing now is to get our slope. If we want to get our slope, and of course this is a negative graph. Looking at this, now we'll draw a slope triangle. Now for us to draw a slope triangle, we place our any point anywhere along the line. So I remember, you don't just draw a smaller triangle. I can have this one here. I can have it up to this point and then join it here. So if I have it here, I can use, for convenience sake, I can use dotted lines. I can use dotted lines to join here. I can equally use dotted lines from here. I can use dotted lines there. I can as well use dotted lines. Now, if I have my dotted lines here, it's just to help me when I am taking my readings. So I can still have this one here, this dotted lines. Now, I have it here. Like I said in my previous video, we can draw an arrow here, make a mark here, make a mark here, change in whatever value you have here. And of course what we have here is I, so change in I. Now I can draw this one as well here. If I draw this one here, I'll have this, here is my change in V. So at this point I am done with this, with my graph plotting. What is left for me now to do is to read what I have plotted. Now, slope. For my slope, I am going to write it outside. Okay, let me use biro. I will use biro so that you can see. Please, on no condition should you write on your graph. Please, on no condition should you write on your graph. So I'm going to write on the graph now. But if you are writing the exam, please do not write your slope on the graph. A page is provided for you where you can write your slope. Now I can have here, my slope is equal to change in my vertical axis, which is V, all over what I have as my horizontal axis, I, which will give me Now I'll read what I have here. This is my V2, what you have here minus what you have here. So here I can have boldly 1.25. So 1.25 minus what I have here. Here is 1.05. 1.05 all over. Now what you have here, remember this thick line is 5 here. So the next line now, this division is 4. So this division is 10. 4 here. Now, of course, if you count down to here, you have 4.9. So I have a 4.9 minus. Now, what I have here, let me adjust this a little bit. Of course, here is a 1.0, which will give me. Now, if you press your calculator, you have 1.25 minus 1.05. It will give us 0.2 all over 4.9 minus 1 will give us 3.9, which will give me 0.2 divided by 3.9. It will give me 0.05. 0.051. I can have 1.0513. Remember the SI unit, it will have the SI. This one is in V, this one is in ampere, so it will now be volts per ampere. Volts per ampere. So this is what my slope is. Now we'll still go back to our question again. Now the next question says, so we have found our slope, determine the slope S of the graph, and C on the vertical axis. So the intercept on the vertical axis. This is time for us to read our intercept on the vertical axis. C is now if we have what we have here is from here now is 1.3. 1.3. Let me adjust this so you can see it very well. 1.3 here. Now after 1.3, the next line, remember this is 1.3, the next one is 1.31. So, and since it's cutting the other one, so we'll have 1.30. This is 1.30. This is 1.30 here. Here is 1.31. So it will now give us 1.305. 1.305. So our intercept is 1.305 because the next one is 1.31. So 1.305. 305. So since this is a V axis, C will give us 1.305 C. Now the next question we have is evaluate K. That K, I will do it elsewhere. Evaluate K. Let me use this paper. K, remember K is equal to C all over V naught. So, which will give us C is 1.305 divided by V naught. Now the V naught is when I is reading 0. So V naught is 1.30. So we're going to divide it by 1.3. This one is corresponding to V naught. So this is I naught, this is V naught. So it is 1.3. So we now have 1.305 divided by 1.3. It will give us divided by 1.30. It will give us 1.004. 1.004. And of course, this one is C is volts, and this one is volt. Therefore, it will cancel. Therefore, we now have that K is equal to 1.009. So that is our answer to that. The next question we have is, next question is question I, where they said here, state 2 precautions you would take if you were performing this experiment in the laboratory. Now, there are lots of experiments, there are lots of precautions to be taken. This is a voltmeter. This is a voltmeter, this is an ammeter. Remember I told you zero error, about zero error and parallax error. So you can as well say, I avoided error due to parallax while taking my readings on either the ammeter or from the voltmeter. That is number 1. Number 2, I noted and corrected zero error of either the voltmeter or the ammeter. Now, the next one is this is a connection. Now, in this connection, you need tight connection of this wire. And why do we ensure tight connection of wires? So that to avoid, this one is for voltage, this one is for current. So you can put it, I ensured tight connection of wires to avoid voltage fluctuation or current fluctuation. You can still say you avoid it. You can repeat the two and differentiate it by saying, I ensure tight connection of wires to avoid current fluctuation, or you can say I ensure the tight connection of wires to avoid voltage fluctuation. Now this is the key here, and of course there is a battery here. So when no reading is being taken, the next thing what you do is to switch this key off. Now you can always say I ensured that I switched off the circuit when no reading was being taken to avoid running the battery down. This thing is very, very important. So when you are not taking any reading, please switch the circuit off to avoid running your battery down. Now, there are other precautions that you would take if you were performing that experiment in the laboratory. And also, if you are using, let's say, accumulator, please, of course, there is an accumulator here, this knife. All you need to do is to clean the terminals. So what you will say is, I ensure that the terminals of the batteries were cleaned. I ensure that the terminals of the batteries were cleaned. Okay, so these from these 4 that I've given you, you can pick any 2. The next question is BI. State 4 factors upon which the resistance of a metallic conductor depends. Now, there are the 4 factors upon which the resistance of a metallic conductor depend. Of course, you can get that from Ohm's law. Now, where we can have that R is directly proportional to the temperature. So you can say that temperature must be kept constant. Now, R also varies directly with L. So you can keep the length of wire constant. Now, we also say that R varies inversely with area. So you can also say area of a wire. So keep that area, the thickness of the wire, please keep it constant. Another one is nature of the material used. Please, if you are using copper wire, please use copper all through. If you are using silver, please use silver all through. So the 4th one is say that yes, nature of the wire. So nature of the wire depends to a large extent the resistance of that wire. And of course, we know that the silver wire is silver is a good conductor than that of copper or aluminium. So these 4 are the factors that you would take. You should keep constant. Okay, the last but not the least question here, they said, explain the specific resistance of a wire. Now, this specific resistance of a wire is nothing but the resistivity of a wire. And of course, we know that the resistivity, rho, is equal to RA all over L. RA all over L. So we now will say that yes, that the resistivity of a wire is a measure of how strongly the material opposes the flow of electric current. And of course, the resistivity of a wire is measured in ohm meter. So you can add that the SI unit of resistivity or the specific resistance of a wire is ohm meter. Okay. Full stop. Now we can, this is where we'll drop the lesson for today. Please do well to subscribe to the channel. If you have not subscribed, hit the like button, give this lesson a thumbs up. Tell me how impactful this lesson is to you. I need it on the comment section because that is what keeps me motivated to continue to create more content for you. Thank you very much. See you in my next video.